welcome back to the deep dive.
Yeah.
So if you're trying to stay on top of this, you already know the basics about air quality. You know about fine particulate matter, PM2.5. Those tiny little particles. We all know they're a major health hazard. I think that's pretty much settled science at this point.
Oh, absolutely.
But for you, our listener, the question isn't really if it's harmful anymore. It's
Right.
how harmful, and more to the point, where's the risk actually coming from?
Right.
So today we're diving deep into this really incredible study that surgically dissects pollution. It asks which specific sources, we're talking industry, farming, cars, are causing the most long-term harm.
And that level of detail, that granularity, is so essential right now.
Why is that?
Well, globally, we have a lot of good data on the general risks of high PM2.5, but the evidence linking, specific sources of those emissions to mortality over the long term, it's still pretty scarce. And that knowledge gap is, well, it's most pronounced in highly polluted areas, particularly in low and middle income countries like China, which is where this study was actually done.
Exactly. So our source material today is a nationwide cohort study out of China. When we say nationwide, we mean it. They tracked thousands of people for a long time to see how their exposure to different kinds of pollution correlated with, well, their survival.
Yeah, this isn't some quick snapshot. The weight of this study is, it's really hard to overstate. It gives us genuine insight into chronic long-term effects.
So where did they get the data from?
They pulled it from the 2010-11 wave of the China Chronic Disease and Risk Factor Surveillance Project, or the CCD-RFS. It's a massive, nationally representative sample, which gives you immense statistical power.
Okay, so just how big was this group? And why does that 11-year follow-up period matter so much?
The initial cohort had over 98,000 people. Ultimately, they analyzed data for just under 97,000 of them.
Oh, wow.
Yeah. The average age was about 46, and they were followed from the beginning of 2010 all the way to the end of 2020. And that duration, a full decade, is just, it's crucial.
Because the effects aren't immediate, right?
Exactly. The really serious health impacts from air pollution, things like lung cancer or chronic heart disease, they often take years and years to develop. So that long time frame lets the study capture those long-term, non-accidental causes of death.
And the researchers that were looking at 3 specific outcomes.
Precisely. They focused on, 1, total non-accidental mortality, which is sort of the big picture risk.
Okay.
2, mortality from cardiopulmonary disease, so heart and respiratory issues. And then finally, mortality from lung cancer. Those 3 really represent the biggest threats from long-term PM2.5 exposure.
Okay, let's attack the technical side of this because this sounds complicated. If you're comparing industry versus transportation, you can't just measure total pollution.
Yeah.
You have to know who owns it, so to speak. How on earth do you do that? How do you trace the family tree of a microscopic particle?
It's a really sophisticated 2-step modeling process. First, they needed incredibly accurate predictions of the total PM2.5 concentration everywhere, down to a very fine grid. For that, they used a machine learning tool, a random forest model, to generate these high-resolution maps. It pulls in everything from satellite data to weather patterns.
So step 1, the model tells you how much pollution is in a specific place. Then what's step 2?
Step 2 is the attribution, answering where did it come from? And for this, they use something called the Community Multi-Scale Air Quality Model, or CMAQ.
CMAQ, got it.
It's a complex atmospheric model that estimates the proportion of that total pollution that's contributed by different sources. It essentially overlays an attribution map saying, okay, on this street, 15% of the PM2.5 is from that industrial zone over there, and 5% is from traffic.
So you're basically giving the particles a signature based on their likely origin.
Right.
That's really impressive.
It is. And this allowed them to break down the total PM2.5 exposure for every single person in the study into 6 specific categories.
And those 6 sources were what exactly?
They categorized them into industry, energy, transportation, residential, so think home heating, cooking fires, agriculture, and then a final catch-all category for other sources. And with that breakdown, they could see how long-term exposure to each specific source correlated with those 3 mortality outcomes.
That level of detail makes the data just incredibly powerful for policy. So let's get to the findings. Starting broad, for total non-accidental mortality, just the overall risk, what did they find?
Well, the baseline finding was very robust. Pretty much all human-caused pollution sources were significantly associated with mortality. No big surprise there.
Right.
But when you look at which sources carried the greatest individual weight, Three really stood out, and we measure this using something called a hazard ratio.
Okay, before you give us the numbers, can you just quickly break that down?
Yeah.
Hazard ratio per IQR increase. For someone who isn't an environmental statistician, what's the simple way to think about that number?
Sure. Think of the IQR as a typical jump in pollution from a less polluted area to a more polluted one. So if a source has a hazard ratio of, say, 1.08, it means that for that typical jump in pollution from that specific source, your risk of death increases by about 8%.
Got it. It's a direct measure of how much your risk gets amplified.
Exactly.
Okay, so with that in mind, what were the top three for overall mortality?
Number one was PM2.5 from industry with a hazard ratio of 1.079.
So a 7.9% increase in risk.
Yes. And very, very close behind at number two was transportation sources at 1.076. And right on its heels, number three was residential sources with an HR of 1.075.
Wait a second, the top three are that close. Industry, transportation, and residential are basically in a statistical dead heat.
They're incredibly close.
I would have bet anything that industry or transportation would be way out in front. I mean, that's what we always hear about, smokestacks and tailpipes.
And that proximity is a really key insight. It tells us that for general mortality, the problem is systemic. It's spread across all our basic activities. In many parts of China, residential sources still rely heavily on solid fuels for cooking and heating.
Ah, so that's a huge contributor.
A huge contributor. It generates incredibly toxic PM2.5, both inside and outside the home. So for overall risk, you have this cumulative effect of industry, traffic, and home emissions that creates a very similar, very broad risk profile.
That makes a lot of sense. Okay, now let's narrow the lens. This is where it gets really interesting, right?
Yeah.
When we look at specific diseases, what about for cardiopulmonary diseases mortality?
Yeah.
Heart attacks, strokes, that kind of thing. Do the rankings shift?
They do, and the shift really highlights the differences in chemical toxicity. When the researchers look specifically at death from cardiopulmonary diseases, the strongest association by far came from transportation sources.
How strong?
It hit a hazard ratio of 1.106.
Wow. Okay, so transportation jumps into a definitive lead for heart and lung issues. Why? What is it about tailpipe pollution that's so good at causing cardiovascular problems?
It's the composition. Vehicle emissions, especially from diesel engines, are just packed with these specific ultrafine particles and other pollutants. These particles are so tiny, they can basically bypass your body's defenses, get into the bloodstream very quickly, and trigger systemic inflammation. And that inflammation is a direct pathway to heart attacks, strokes, blood vessel damage.
So it's a direct assault on the circulatory system.
A direct assault. Industrial sources were second with an HR of 1.085, and residential was third at 1.070. So again, it's the urban and industrial sources that really dominate this category.
So far, this kind of confirms what we might have guessed about urban pollution. But this next part of the study is where it seems to just completely flip the script. The findings for lung cancer mortality.
Yes. The findings for lung cancer were easily the most surprising, and they also showed the highest risk factors in the entire study. The exposure response curves were much steeper.
Meaning a little bit of pollution goes a longer way.
A much longer way. A small increase in exposure led to a much bigger spike in risk. And the strongest association for lung cancer mortality was from agricultural sources.
I'm sorry, did you say agriculture?
Agriculture.
Yeah.
With an extraordinary hazard ratio of 1.256.
Wait, let me get this straight. Farming-related emissions. So, like fertilizer dust, ammonia from livestock, that was the single biggest risk factor for dying of lung cancer in this entire study.
That is precisely what the data showed. At 1.256, agricultural PM2.5 had the highest hazard ratio of any single source for any disease they looked at. For lung cancer, it stands out as the most powerful risk factor by a significant margin.
That is, I have to admit, that is not what I expected at all. If I'm a policymaker, I'm putting all my money on smokestacks and tailpipes. This just changes that whole conversation. What came in second and third?
Second strongest was industrial sources with an HR of 1.235, still very high. And third was transportation sources at 1.204. So industry and transportation are clearly still major carcinogenic threats.
Of course.
But the dominance of the agricultural source is the really critical and frankly unexpected piece of this puzzle.
Is there a chemical reason for that? Why would farming emissions be so disproportionately carcinogenic?
It goes back to the chemical makeup. Industrial and transport pollution often contain things like heavy metals, elemental carbon, soot, basically.
Right.
Agricultural PM2.5 is different. It often comes from fertilizer application, livestock waste, maybe some burning of crop residue.
Yeah.
This produces pollutants like ammonia, which then transforms in the atmosphere
Into what?
into what we call secondary inorganic aerosols, things like nitrates and sulfates. And these secondary particles, they're smaller, they travel further, and it seems they are particularly potent lung carcinogens over a long period.
So it's not just about the soot and smog we can see. It's about these invisible chemical reactions happening in the air around farms.
It really underscores the whole point of the study, which is that the toxicity of PM2.5 is not uniform. It varies distinctly depending on where it came from. The components from agricultural emissions appear to be uniquely dangerous for the lungs.
So if we pull all this together, what's the big takeaway? What does this mean for the real world?
I think the main thing is that these findings provide crucial evidence for developing what you might call health-oriented policies.
Meaning what exactly?
Well, historically, a lot of pollution control has been a bit of a blunt instrument, just general caps on total emissions.
Sure. Clean the air, period.
Right. But if you know that industrial and transport emissions are most devastating for heart disease, while agricultural emissions are disproportionately linked to lung cancer, you can be much more surgical. You can use targeted interventions.
So you could design a policy specifically to reduce heart attacks in a city?
Exactly. You would intensify regulation of vehicle emissions and factory output in dense urban areas. But an effective strategy against lung cancer has to look far outside the city. It has to address agricultural practices, fertilizer use, waste management, things like that.
So you're tailoring the policy based on the disease profile and where the emissions are coming from. That could maximize the health benefits for every dollar you spend?
It could, yes. It's no longer just about cleaning the air in general. It's about cleaning the right source to get the right health outcome. That's the power of this kind of study.
That kind of precision really is the future, isn't it?
Uh-huh.
We've moved past just pollution is bad, and we're now in the era of this specific pollution from this sector causes this long-term disease.
That's a perfect way to put it.
So let's just quickly recap the risk landscape we've mapped out. For total mortality, the big picture, the risk was spread pretty evenly between industry, transportation, and residential sources.
Mm-hmm.
For cardiopulmonary diseases, heart and lungs, the specific chemistry of vehicle exhaust put transportation at the top of the list.
Right. And then the big one, the real surprise, was lung cancer mortality, where agricultural sources came out as the single highest risk factor in the entire study.
It just reinforces that knowing the source, separating a tailpipe from a fertilized field, it fundamentally changes how we have to think about public health.
It really does. Granularity is power.
So let me leave you, a listener, with a final thought on all this. If agricultural PM2.5 shows the highest individual risk for the deadliest outcome here, lung cancer, how might policy changes in land use, or soil management, or even just different farming practices, how might those, rather than just more controls on city traffic, become the single most effective tool for saving lives in highly polluted areas? It really demands a shift in focus, one that asks us to look way outside the city for the solution to one of our biggest public health crises. We hope this deep dive helps you ask those informed questions.